Hello. Chapter 3 is about sets, operations, and some properties, some notation. So we learn all these things about sets and more. So let's start with sets. What do we mean by sets? It's not to ask what's the set of something. And to classify groups, this is something natural. We use sometimes groups, we use the word sets. Here we will focus on the word set, and we consider how those sets overlap with each other. We can use these sets to understand relationships between groups and to analyze survey data. Now, what do we mean by set? Set is a collection of distinct objects. Distinct objects, that means each object is different from the others, called elements of the sets. But actually, sets do not have definitions, rigorous definition in mathematics. But this is just description of a set. A set, we can think of set as collection of distinct objects. But we know that the word set and word collection almost mean the same thing. So we are in that loop, set, collection, group. So we don't have specific definition for or mathematical definition for set, but this is just to make it easier for you to understand what do we mean by the word set. So set means collection of distinct objects, and these objects are called elements of the set. Now we can describe a set by defining or describing the content, or by listing the elements of the set. And we usually use curly brackets to enclose these elements like this. So we put the elements inside it here, and between any two elements we put comma. So this is the set notation that we usually use. Now, we have some examples of sets defined by describing the contents. For example, the set of all even numbers. Even numbers, for example, 0, 2, 4, 6. These are called even numbers. They can be divided by 2. If we use the set notation, the curly brackets, we can write it this way. And we usually use capital letters to denote those sets. For example, we call the set A or B or E or anything. For example, here, if you have even numbers, you may want to write it as E. And that's fine. You can use any capital letter to denote sets. Now, part B, the set of all books written about the travel to Chile. So these are, here we cannot write all these books, so we just describe them, describe the content. Now, some examples. So sometimes we can write the elements and describe the content by listing the elements. And sometimes this is not easy to be done. For example, for even numbers, we could list some and then put 3 dots. That means we continue in that manner as 6, 8, 10, etc. So the reader can understand that these are all even numbers. So this is continued. Now, a set of all books written about travel to Chile. This is cannot be, or it's not easy to find all these and to list them here. So we just describe it. We can say that this is the set of all these sets, or these elements, these books. Sometimes we use a notation that's called building notation. For example, if we want to write this, it's not easy to write this every single element, but we can write it this way. B denotes the set of those books, and we can describe it as something X, some variable. This variable represents each book, such that this vertical line is read such that X, this variable, is a book. This is an individual book written about travel to Chile. And that's it. Here we couldn't list the elements, but we could describe the elements. This is sometimes called set builder notation. If we can write some or name some elements, we can use this notation by listing elements. If we can't, we just use some characteristic of these elements. So this is read, the set B is the set of all X such that X is a book written about the travel to Chile. Now, for example, if we have a specific book, we can say that book is a book written about a travel to that place. Now, so we have different ways to define the set or to write it, either by listing all elements or by just writing the characteristic of these elements. Now, here in example 3.2, we have some examples of sets defined by listing all elements. For example, this set is the set of the numbers 1, 3, 9, and 12. Here, this set, we can see that all elements are listed here: red, orange, yellow, green, blue, indigo, purple. All elements are listed here. Now, notation with sets. Commonly, we use a variable to represent a set to make it easier for us to refer to that set later. For example, we can say this is the set A. Instead of writing everything that set or the set notation, we just write the element A. We usually use capital letters for sets and small letters for elements as needed. Now, this symbol is read is an element of or belongs to. Sometimes read or belongs to. What does that mean? That means an element that belongs to a set. So, for example, little a, this element, belongs to the set A. We can write it this way. Or the element C belongs to the set A, and so on. So this is read belongs to or is an element of. So this is one notation that's very important, and this describes a relationship between an element and a set. So this is relationship between element and a set. So in that case, we use belongs to or as an element of. Now we have another notation that's used between set and another set, but this is called subset. So a set that's part of another set, we use subset. So subset of a set A is another set that contains only elements from the set A, but may not contain all the elements of A. If B is a subset of A, we write B subset of A. So this is another notation we use, but this is subset notation, or this is the symbol we use in this case. And as you can see here, we have equal sign or symbol. We use it if we are not sure if B is all elements of A, because any set is subsets of itself. Sometimes we write a proper subset. We don't want write this equal here, so we call it proper subset. Now, for example, the set A consists of the elements 1, 3, 5. A might be a subset of a larger set. For example, it might be a larger subset of the set 1, 2, 3, 4, and 5. As you can see, we have 1 here, we have 3, and we have 5. So A is a subset of B. We either write it this way or we put the equal sign. That does not change anything. So we can put equal sign, or we can write it A subset B, subset of B, and that's it. Okay. So this is smaller, this is larger usually. Okay, that was section 3.1. In section 3.2, we learned some operations on sets. So usually sets interact. So we can, sometimes we put all the elements in one set and that's called union. Sometimes we find the common elements and that's called intersection. And sometimes we want to find the elements that do not belong to that set, but they can form a larger set that's called universal set. So here the union of sets, we usually use letter U, and intersection we use this symbol, and but actually you without tail, we don't put tail here. And the complement, for example, for the set A we use the letter C. Now what do we mean by these? The union of a set of two sets contains all the elements, we put them in one set, contained in either set or both. The union is denoted as this, so A union B. More formally, if an element belongs to the union, that happens if this element is either in A or in B or in both of them. Here in this example, we have sets A and B. A consists of the colors orange, yellow, red, and B consists of colors orange, brown, and purple. And set C consists of colors pink, brown, red, yellow, orange, purple. We want to find A union B, so we want to union A with B. So that means we'll put all the elements together, but we need to remember some things here. So let me write it here, some properties of sets. We cannot repeat an element. So repetition is not allowed within a set. So we cannot write 2, 2, 3. So this is wrong. Instead, we write 2, 3. We just name the element just once. And order, another property, order does not matter. So order is not important. So for example, the set A is 2, 3 or 3, 2. So order is not important, and the repetition is not allowed within a set. These are important notes to keep in mind when we write the sets. So when we make union A with B, so A consists of orange, yellow, and red. Now we want to add to this set the set B, orange, brown, and purple. But as you can see here, we have orange written twice. So we just cancel one of them and we write it this way: orange, yellow, red, brown, and purple. Okay. Now let's find B union C. We add the elements of C to the elements of B. B has orange, brown, purple, and we add the elements of C. So pink, brown, but we don't want to write brown because it's already there. Red, yellow, we add it here, yellow. Orange, it's already there. Purple, already there, so we don't need to write them again. So that's it. That's what we mean by union, to put all the elements in one set. Now we have intersection. This is the symbol we use. The intersection of two sets contains only the elements that are in both sets, the common elements. Common elements. So if an element belongs to the intersection, then it belongs in both of the sets, both of the two sets. Let's take an example. If letter of set A consists of orange, yellow, and red colors, B consists of orange, purple, brown, and purple, and set C consists of pink, brown, red, yellow, orange, and purple, we want to find the intersection first. A intersect C. So this is set A. and this is set C. We want to find the common elements, so let me use the red color to find the common. We have orange here, and it's not, no, it's here as well. So this is one of the common elements. And we have yellow, so it's in both. We have red here and red here, so it's in both. So the common elements are orange, yellow, and red. That's the intersection. Now, if we want to find B intersect C, B and C, we want to see what are the common elements. We have orange, we have a brown, and we have purple. And we can see here that the set A is subset of the set C. We also see that the set B is subset of the set C. That means it's part of it. But B is not a subset of A. And the element, for example, purple, this is element, does not belong to the set A. So pay attention to the notation that we use, contained or not contained. By the way, I can put equality here, but that's because this is properly included or subset, we don't need to put it. This is element, so we use belongs to or element of, and it's not element of A. That means we cancel it. Now the third operation is the complement of a set that contains everything that's not in that set, in the set A. We use A, C, or A dash, or sometimes negation of A to determine or to describe the complement. For example, we have the set A, or that consists of the colors orange, yellow, and red. B consists of orange, brown, and purple. And set C, pink, brown, red, yellow, orange, and purple. We want to find B complement intersects C. So the first step to find B complement intersects C, we find B complement. What are the elements that do not belong to B? So we want to find B complement. B has orange, brown, and purple. What do we mean? What do we need to complete this, to include all these colors? So it has orange and brown. It has purple. So it needs yellow. It needs pink. It needs red. It needs anything else? No, that's it. So this is complement of B. Now we apply the operation B complement intersects C. So the elements in both B complement and C, what are the elements? Yellow, pink, and red. Yellow, pink, and red. So that's B complement intersect C. Now we have A intersect B complement. Now A consists of orange, yellow, and red. The complement does not have orange, does not have yellow, but it has red. So the only element is red. So this is sometimes called singleton. Just one element. So we find the sets A and B complement, and then we find the intersection. Now let me say something about the empty set. The empty set. The empty set is denoted as phi. This is read phi, sometimes written this way, phi, Greek letter. That denotes empty set that does not have any element. Or sometimes we use curly brackets but nothing inside them. This is a read empty set, or this denotes the empty set. Now we have a set that's called universal set. That's a set that contains all the elements, including itself, usually denoted as U. We usually use the letter U. And the elements in the universal set, the element are defined by the context of the given set. Let's take an example. We might be what might be the universal set for the given set. For example, set A, set of books. Can we describe it? So we just write U is set of all books. Now, set of friends on social media. This is also universal set. Now here we use for universal set, it's not like the union. It's not union, it's letter U. Some people write it this way. Some people write it this way. Some people write it this way. So it doesn't matter which one you use. If you can write it curly as this, that's fine. If you just write it this way as letter U, but without the tail, that's fine. Okay, so this is set U. Let's use that simple. So this is letter U and the set of all books. Here, set of friends in social media. Also, this is U, set of all friends on social media. So that means we have sets or social site. So we have sets that we cannot find or list all of their elements. So these are universal, called universal. Set of numbers, same thing. These are universal sets. Now, for example, we may be given this universal set U, and we have set A. What is A complement? A complement means all elements that do not belong to A but belong to the universal set. So A has 1, and that's in the universal set, 2 and 4. So A needs the elements 4, 5, 6, 7, 8, and 9 to complete the universal set. So to be as in the same size as the universal set. So we write 4, 5, 6, 7, 8, and 9. So this is the complement. This is what the set A needs to be equal to the universal set. So this is the complement. The elements that do not belong to the set A but belong to the set U. Another example, let U be the universal set, and it's 1, 2, 3 up to 20. Let A be the numbers 2, 5, 7, 8, 10, 11, 12, 15, 16, 20, and B has these numbers. We want to find A intersect B complement. So let's find B complement. What is the complement of the set B? Set B has the elements 1 from the universal set, 2, 3, 6, it's somewhere here, 7, 9, 11, 14, 16, 19, and 20. So what is the complement of this? What is the complement of B? 4, because 4 is in the universal set. 5, it has 6, 7, it needs 8, it has 9, it needs 10, then 11, 12, and 13, then we have 14. 15 is missed here. 16, 17, we're missing 17, 18. This is the complement of B. The complement of B are the elements that belong to the universal set, but they do not belong to the set B. Now we want to find A union B complement. So what is the intersection? This is A intersect B complement. What is the intersection? What is the common elements between A and B complement? Let's try to find this. So we have 2 is not in both, 5 is in both, 7 is not in both, 8 in both, 10 is in both, 11 not in both, 12, 13 not in both, 15 is in both, 16 not in both, 20 is not in both. So what is the intersection? The intersection is 5, 8, 10, 12, and 15. If we want to find B intersect A complement, let's find A complement first. What are the elements that are in the universal set but are not in set A? So the universal set has all elements from 1 to 20. Set A is missing 1, 3, 4, 6, 9, 13, 14, 17, 18, 19. Now we find B intersect A complement. So the common elements between B and A complement. Let's find them. So we have 1 here in A complement, and it's also in A in B, so this is common. 3 in both. 4 no. 6 yes. 7 no. 9 in both. 13 no. 14 yes. 16 no. 17 no. 18 no. 19 yes. So these are the common elements between B and A complement. So that's the intersection. Okay.